These are Colossus and Guardian. They are probably one of the first fictional examples of generative adversarial networks. It started with Colossus in a science fiction movie of, I think, 60s or 70s. And until Colossus and Guardian, two separate computer networks, until they discovered each other, they were separate, they were uh, working in isolation. But right after discovering each other, they started as adversaries. It didn't take long. After building their own language to exchange information, knowledge, they became actually like they started working together. This type of building their own language is actually something observed in the past with human twins raised in social isolation as well. I believe actually Noam Chomsky used that as one of the evidences when he was building his theory of language is inherent in human beings. This is HAL 9000. It was close to what we can call an artificial general intelligence. And of course, with it, it was demonstrating the potential risks of it. It's from the movie based on Arthur Clarke's 2001 Space Odyssey. And it was a computer completely responsible for managing everything in a spaceship and helping the astronauts in it. And then we have iRobot. This is um, Asimov's book, a series of books actually on robots exist, developed by Asimov, written by Asimov. It includes possible cases that force us to consider the importance of ethical AI. The three laws of robotics developed by Asimov in these series of books are very famous. And then we have Gateway. Gateway starts with an example of an elementary natural language processing application. One of the greatest authors of science fiction, he said once, a good science fiction story should be able to predict not the automobile, but the traffic jam. Of course, we are not going to write a science fiction story, but we are going to use some predictions from one already written by this guy. It's The Gateway of Frederick Paul. This is Siegfried von Schrink, the digital psychoanalyst. In the book Gateway, it started as a procedural program, functionally an NLP, natural language processing application. But in time, throughout the book, during the adventures, it became more sophisticated with reinforcement learning and by changing its own code and parameters. This was based on interactions with human patients. He was able to, or Siegfried von Schering was able to help human patients as a cheap alternative digital psychoanalyst. This reinforcement learning technique is actually similar to today's reinforcement learning from human feedback method applied to large language models. And then we have that funny guy again, funny and smart guy again. But this time I didn't pick. Paul picked the name for his digital personal assistant in his book. Albert evolved from Siegfried von Schrink with the availability of huge compute power. Essentially, in the book, that compute power became suddenly available using alien technology. But it was similar to today's transformers-based deep learning architecture, maybe. So in today's realm, well, Siegfried von Schring was only 64 gigabyte, the initial model. And of course, the book was written in 70s, so we can understand how 64 gigabyte was a huge thing at that time. But today's data centers would look alien to alien technology. to people of 70s. So we can say that today's transformers, which have been made possible but by the huge compute power of today's data centers, is similar in a sense compared to what's depicted in the book. Albert was still a single entity. It was akin to a large language model, depending on this brute compute force, albeit it was still limited in many ways, and we could see it in the book. In our previous Quik-Tech-Talk, we talked about one of the most fundamental laws of the universe, the second law of thermodynamics. The premise was it almost always applies, so we can reuse that law to see how things evolve around us, what to expect next from new things coming up. The example was a computer cannot grow and grow indefinitely. We have to create networks or clusters or similar applications where multiple computers can work together to produce benefits for us. It also applied to machine learning models or many other things as we discussed. And at the end, I wanted to share with you some ideas to exercise, like how can we, for example, predict the future of large language models or Bitcoin or quantum computing. So as you might have already noticed, we are already doing that by deriving some ideas from Paul's Gateway book. One of the things towards the end of the Hichi saga, Gateway was probably one of the first books of a series of books, which are called Hichi saga. Polymath appeared. It's a shortened word of the word polymath, of course, and Paul himself was a polymath. Polymath is what we can call, with using today's terminology, is a multimodal network of specialized language models. It works like this. Today's large language models are called large because they are large compared to what we had 5 years ago. But they are not likely going to stay large or be large, let's say in 5 or 10 years. There will be a need to improve them, but similar to the single computer unable to produce benefits as it becomes larger, probably we will not get the same level of benefits by making large language models even larger. It hits the law of diminishing marginal returns, which is another term for our law of entropy, but it is used in mostly business and economics. So specialized language models come into place. Actually, this has already started. Hugging GPT, Gorilla, Task Matrix are various implementations of this idea. What happens is a rather generalized large language model, such as ChatGPT, act as a controller or the brain of the system, which coordinates a solution for a problem by planning and delegating subtasks to different APIs. And those APIs might be connections to other specialized language models or not even uh, other types of deep learning networks specialized on image recognition, voice synthesis, or some other tasks we have been doing with them in the past. Another prediction we can make based on this and extrapolating this idea is, imagine what would come out of this if, for example, Elon's Neuralink is connected to a specialized language model or a large language model. Or even simpler, imagine what would happen if we fine-tune or RAG a language model with all the emails, all the conversations, recorded conversations, and all other writings of a human being. In Paul's books, this made the protagonist, Robinette Broadhead, an immortal being. Essentially, his brain was kind of uploaded to a language model. So what do you think would come next if we extrapolate even further? That's a question I want to ask for you to think about, and maybe we can explore more in one of the next sessions in the future. Thank you.